This is section 8.1, problems 5 and 6. Problem 5 says to predict the general term for the sequence. So the first thing you're going to do is, I like to make a t-table. So remember that a sequence, the domain is 1, 2, 3, 4, and so on. That's the domain. So you have to show that domain. So we usually call the domain N with sequences. So 1, 2, 3, 4. And then what value is with the 1? Well, that's the 3 that's in the sequence. And so that's this 3 here. And then the second term is the 7. And the third term is the 11th. And the fourth term is the 15th. So that's the first thing I do, is to put it into a table. Now, if I look at what is called the common difference and see if it's the same for each one of these terms. So from 3 to 7, that goes up by 4, and from 7 to 11, that goes up by 4, and from 11 to 15, that goes up by 4. So since all of these are the same, then when I get ready to start writing my answer, the first thing I write is for N. And the 4 comes from what I've circled here in red, and of course it's N because the X value is in these situations. All right, now, that's our general term. Now we've got to check it and see if it works. So now we're going to take the first term and we're going to plug it in. So we're going to say, all right, 4 times 1. Well, 4 times 1 is 4. Is that actually the first term? Is that this first term? It's not. How can I make that 4 become a 3? Well, don't I have to subtract it by 1 to make it become a 3? So now my general term is 4 times n minus 1. Now we want to check that. So let's check it with a different term. I'm going to jump down to the fourth term. So I'm going to move all the way down to the fourth term. And what I want to see is if I put in 4, will I get this 15? If I put in the 4, will I get this 15? So let's see. 4 times 4 minus 1, does that equal 15? And yes, it does. So I know that my answer is correct. The general term for this sequence is 4n minus 1. All right, let's go down to the second one. So the first thing I want to do is put it in a t-table where n is 1, 2, 3, 4 again. And then the y value is the terms of the sequence, so 4, 16, 64, and 256. Now, looking for a relationship between those numbers. So let's see. The 4 to the 16, that goes up by 12. And the 16 to 64, well, that certainly doesn't go up by 12, so that doesn't help me any. All right? Let's see. 4 to the first power is 4. 4 to the second power is 16. 4 to the third power is 64. So my general term would be 4 to the n power, and that's the answer. And that's how we write a general term for an algebraic sequence.